Okay, hello once again. You've made it to the final IDAH2O online module. If you're like me, you're itching to get out into the stream and try out some of the stream assessments in person. But there are a few final items to cover. First is that you might not be interested in monitoring a stream. Perhaps you live on a lake or have a pond in your backyard. While IDAH2O specializes in assessing wadable streams, there is a standing water assessment protocol too. Standing water refers to natural lakes, man-made reservoirs, and smaller ponds. All three assessments are combined in one data form. In this module, I will refer to all standing water as lakes just to keep things simple. But remember, while there are many similarities among these types of standing water, there are also differences. So lakes act as sinks or storage areas for water and also for many types of pollution. Sediments, chemicals, and nutrients that flow down tributary streams are concentrated in the bottom of lakes. Water flowing out of lakes are sometimes cleaner in some ways than water flowing in. Sediment and phosphorus usually drop out of the water column and into the lake bottoms, though lakes contribute other pollution types like increased temperatures and cyanotoxins. Professionals use sophisticated methods to sample water throughout the water column. A comprehensive lake monitoring program will have sample sites along the edges for early detection of pollution impairment and deep mid-lake locations to show long-term trends. You will geolocate and register your site with the IDAH2O program just as you do with stream sites. If you want to monitor from one dock or shore site, that's fine. You can still provide informative data. But you can also monitor two lake sites, say one from a dock and one from the deepest point in a boat. That is even better. Always wear your PFD or life jacket, and don't sample in rough conditions, rain or electrical storms, with thin ice or other unsafe conditions. IDAH2O recommends also monitoring the inflow and outflow of lakes to provide a more comprehensive data about how the lake changes the water qualities and how the water flowing out is different from that flowing in. You should monitor a lake about monthly, starting right after ice out through just before it freezes over again in the fall. The habitat assessment should only be done once, sometime in July. Our hydrologic information system can handle more data too, so if you would like to contribute more frequently, that's okay too. IDAH2O equipment is best suited for studying the surface or epilimnion of the lake. Monitoring should be done at about 0.5 meters in depth, that is, just below elbow depth. Only the Secchi disc can be lowered down into the water column to determine transparency. Remove your sunglasses and lower the Secchi disc over the shaded side of the boat and into the water. Continue to slowly lower it until you can't see it anymore. Mark the tape measure or rope at the surface with a clothespin or paper clip. Lower it a little more, then slowly bring it back up until you can see it again. Mark this measurement at the surface. Bring the disc back into the boat and find the midpoint between your two marks. This is the average of the two readings and is considered the Secchi depth. If the Secchi disc hits bottom before it goes out of view, note that depth in the form and add a comment that you hit bottom and could still see the disc. Or use the transparency tube instead and note the depth in centimeters. If rooted vegetation gets in the way, move over a little and try again, or just use the transparency tube. Remember that your surface monitoring will miss important phenomena deeper in the water column. Temperature will drop in deeper lakes at a point where the sunshine stops penetrating. This metalimnion causes the lake to stratify into two distinct layers with warmer water floating on top of colder, more dense water. You need to use an electronic meter with a submersible sonde or probe with a long cable to measure meter by meter differences in temperature, dissolved oxygen, and other factors. IDAH2O does not collect these data, but many other citizen science programs do. For the assessment, follow the same general guidelines as described for stream assessments. Remember that some stream monitoring techniques don't make sense in a lake. Stream velocity, for instance, and Woolman pebble count are not included in standing water assessments. The biological assessment includes a question about whether you can see an algal bloom present. Look for green scums, algae mats, or green color evident. You can also complete a macroinvertebrate survey along the shore and submitting those data using the biological assessment form. Aquatic invasive species are a threat to lake and stream ecosystems, and some can lead to disastrous results for irrigation systems, hydroelectric plants, and recreation areas. Plants can grow unabated, choking out fish habitat and making for dangerous swimming conditions. Mussels will grow so quickly and thick that they can clog water intakes and damage hydroelectric plants. Non-native snails, crayfish, fish, and amphibians can disrupt ecosystems by eating everything in sight. Humans spread invasive species from places far away to new areas without natural balances. Many species enter our waters in the bilges of boats and ships. Waders with felt are particularly susceptible to movement of New Zealand mudsnails and some aquatic plants. Some types of anchors and boat engines can also harbor invasive species from one place to another. Remember the mantra to always clean, drain, and dry. Clean all mud and plant material from your sampling equipment and waders. Drain all standing water from your boat's bilges, motors, anchors, and other equipment. Dry all surfaces and compartments. Here are a few invasive species of particular concern for Idaho. Eurasian Watermilfoil is a submersed macrophyte or aquatic plant that overwhelms shallow lakes by forming dense beds. While it creates lots of dissolved oxygen during the day, as all plants do, it consumes dissolved oxygen at night. This exacerbates an already wildly swinging DO situation for fish and can basically make entire bays uninhabitable for fish. It is highly invasive, being very difficult to manage once it is in place. If you've ever tried to swim through a dense milfoil area, it's very difficult. I have heard of swimmers becoming entangled and drowning, although I can't verify that was the cause. There is a native version, the northern watermilfoil. These have fewer than 12 leaflets on their compound leaves, where the Eurasian version has more than 12. These two will hybridize, creating a plant that's even more difficult to control with herbicides. New Zealand mudsnails were originally found in the U.S. in the Snake River of southern Idaho. These tiny pinhead-sized snails reproduce very quickly, taking over entire areas of a river. They feed on so much of the available algae that it reduces the food source for aquatic macroinvertebrates and therefore reduces the food available to fish. They are not at all nutritious to fish and in fact can pass through a fish's digestive tract unharmed. This is one species that is particularly susceptible to being caught in the felt underfoot portion of waders and inadvertently spread to new waters. Zebra mussels and their cousins quagga mussels have become a massive nuisance, causing great economic hardship in the Great Lakes and other areas where they have invaded. These mussels were first discovered in the Great Lakes areas in the 1980s, likely being transported from the Caspian and Black Seas in the ballast water of transoceanic cargo ships. Adults can live up to 30 days out of the water and can produce prolific offspring. A water body with a new invasion can go from a beautiful beach to a stinky, sharp beach overwhelmed by mussels in 2 years. That's what happened to the beach here on the bottom left of this slide. That was a beautiful beach 2 years before this photo was taken. Unlike native mussels, they attach to almost anything and will grow inside of irrigation pipes and hydroelectric intakes, badly clogging them. If you find mussels attaching to a dock, piling, or other hard surface, let me or the Aquatic Invasive Species program know. Idaho has developed an Aquatic Invasive Species program housed within the Idaho State Department of Agriculture, along with the Terrestrial Invasive Species program. In North Idaho, Kim Holzer, Ph.D., is the coordinator. Each region in Idaho has a program coordinator plus all other knowledgeable staff who can assist you if you think you see an invasive species or just aren't sure. You can find lots of information about the program and about invasive species of concern via their website here on the screen, plus elsewhere in the module. It's always better to contact me or an invasive species specialist, even if you aren't sure. It's our job to field questions and inquiries about potential invasive species. Remember, there are many more aquatic invasive species in Idaho than the 3 I mentioned here. There's just not enough time to cover them all in this workshop. If you wish to continue with additional citizen science initiatives, one possibility is to add the Crayfish Observation Citizen Science Program to your stream or lake monitoring. IDAH2O is the Idaho coordinating organization for the River Mile's crayfish programs. The River Mile began studying population dynamics among native signal and non-native virile or northern crayfish in Lake Roosevelt National Recreation Area back in 2010. The River Mile also does water quality monitoring and in fact is using the IDAH2O protocol for some of that. With distributed citizen scientists catching and identifying crayfish species, the researchers studying how invasive species move into new areas will have a vast data pool to work with. You can take an additional online course of study developed in tandem with the River Mile and an educational nonprofit called Engaging Every Student. Then anytime you catch a crayfish in your keck net, you can document its size, species type, and other important data. Crayfish are easy to identify to species since there are only a few types, and they are plenty big enough to see and hold. In addition to the crayfish study, IDAH2O is working with NOAA's Phytoplankton Monitoring Network to help understand how cyanobacteria blooms develop in lakes. In 2018, IDAH2O started working with the Phytoplankton Monitoring Network to provide more robust lake monitoring opportunities for Master Water Stewards. NOAA provides occasional training for new volunteers and can provide equipment like microscopes to those who commit to regular biweekly monitoring on the lake. You can learn more by contacting me or the PMN program directly. Congratulations! You're almost done with the classroom online version of the IDAH2O Master Water Stewards training. We hope you gained a lot of new information, and if some of it was review, I hope you still found it interesting. You can now feel more confident in your knowledge about water quality issues and hopefully can spring some good conversations with people you know about your new knowledge. If you want to continue with studying water quality and would like to start monitoring your local stream, let the IDAH2O coordinator know and find an in-stream monitoring workshop scheduled in a place near you. During the field assessment portion of the workshop, you will get to try each monitoring technique on your own. This will increase your confidence in your monitoring skills. It will also allow me or the IDAH2O coordinator to certify that you, indeed, know how to properly take all the measurements as a part of IDAH2O's Quality Assurance Project Plan. If you participate in a field workshop, remember to dress for the weather. Unless conditions are unsafe, I will hold the workshop rain or shine. Also be ready for uneven surfaces, bugs, etc. Okay, that's all, except for one more final quiz. Thanks again. I hope you've both enjoyed this workshop and feel smarter about water. We'll see you in a little bit. Call me anytime.